Section 7.2, we're going to be talking about multiplying and dividing monomials, and if we're going to multiply and divide them, it might be helpful to know what they are. So a monomial is an expression with only one term. So it can't have any addition or subtraction signs because that would separate new terms. It can have variables, it can have constants, it can have exponents. It just can't have addition or subtraction. So here we have some examples. X would be a monomial, just one variable by itself. 10, just a constant by itself, is a monomial. This is also a monomial, 3x squared y to the fourth. We have constants and variables being multiplied, but there's no addition or subtraction, so it's still a monomial. Same thing with this example here. Over here, these things are not monomial. So f plus 10, this is two terms. Here's a term, there's a term. You also cannot have variables on the bottom or the denominator of a fraction, so we can't divide by variables, and we can't have variables under a radical, so under a square root, cubed root, anything like that. Alright, so these things are not monomials, these are. Okay, so I'm going to multiply and divide monomials. When we do this, we're going to start with any coefficients or any constants. So I'm going to multiply numbers first, then variables. I'm going to use the laws of exponents that we just learned, and I'm going to also always follow order of operations. So I have this example here. The first thing I'm going to do is start with the coefficients. So I'm going to multiply 3 times 5. Okay, and then I'm also going to multiply x to the 6 times x squared. So 3 times 5 is just 15, just like it has been since you learned it in, I don't know, 2nd or 3rd grade. And then x to the 6 times x squared, remember we learned laws of exponents. If we're multiplying, I'm going to add the exponents together, so this is x to the 8th. Alright, so 3x to the 6 times 5x squared becomes 15x to the 8th.
It's time to get upon your feet. It's easy to do, just follow me. Move it out. That's it. Take it back. And then step left, then drift, step right, and then drift, crisscross, and do the man-made, crisscross, and do the man-made. Now jump, jump, wiggle your rump, and walk it out like granny.
Alright, hope you guys enjoyed that. I had a request to put some random things in the middle of videos just to keep them interesting, so be on the lookout for that. It won't be the same every time. It may not be in every video, but just throw some random things in there just to keep it interesting. So now we have some more examples. Alright, we're still multiplying, so remember constants or coefficients first. So negative 4 times 3 would be negative 12. Then I'm going to multiply the a's times the a's and the b's times the b's. So a to the 3rd times a squared multiply, so I'm going to add the exponents. So 3 plus 2 would be 5. Okay, then I have just b times b to the 5th. Remember, just b has an imaginary exponent of 1. So b to the 1st times b to the 5th would be b to the 6th power. Okay. Here in this example, now I have things being raised to power. So if you remember order of operations, it's parentheses and then exponents. So I don't want you to get confused. I know there's parentheses here, but there's nothing inside the parentheses that I can do further. B squared is just b squared. There's nothing I can do with that. So I'm going to raise each of these to these powers. So b squared to the 3rd power. Remember, when you're raising a power to a power, you're going to multiply those numbers. So b to the 2nd to the 3rd power would be b to the 6th power. A squared to the 4th power would be a to the 8th. And then c to the 3rd power would be c to the 9th. Alright, over here I have 1/4 times this, so again I'm going to follow my order of operations. I'm going to distribute this 1/4 first and then multiply by what I have over here. So 1/4 times 2 is 1/2. Alright, and then x to the 3rd y squared. Alright, so we have that times 8x to the 5th y. Alright, so remember constants or coefficients first. So 1/2 times 8 is 4. X to the 3rd times x to the 5th. Add the exponents gives me x to the 8th. Y squared times y, and remember this is to the 1st power, so 2 plus 1 gives me y to the third power. Alright, then we have some division examples. When you're doing division problems, I really want you to think about breaking this up into 3 separate problems. I have numbers to divide, I have a's to divide, and then I have b's to divide. So I have negative 3 divided by 9, and then I have a to the 4th divided by a, and then I have b to the 7th divided by b squared. Alright, well, negative 3 divided by 9, all I can do is simplify that to negative 1/3. A to the 4th divided by a, remember there's a 1 there, and when I'm dividing, I'm going to subtract exponents, so 4 minus 1 gives me a to the 3rd. B to the 7th divided by b squared is b to the 5th. Alright, here I have this whole thing raised to the 2nd power before I do my division. So I'm going to raise everything in this parentheses to the 2nd power. So 4 squared gives me 16. R squared squared is r to the 4th. S to the 3rd squared would be s to the 6th. Divided by 3 squared, which is 9. R squared would be r squared. And then s squared. Okay, so then again, I'm going to break this up into different problems, dividing my like terms here, or like variables, like constants. So 16 divided by 9 is just 16 divided by 9. There's nothing I can do to simplify that further. R4 to the 4th divided by r squared, 4 minus 2 is 2, so this is r squared. And then s to the 6th divided by s squared, 6 minus 2 gives me s to the 4th. Alright, now one thing I want to note, you might occasionally see these written a little bit different. So instead of negative 1/3 times this, you might see it as negative 1 a to the 3rd b to the 5th divided by 3. Those are the same thing because I still have that negative 1/3 fraction right there. Same thing was this. I could write this as 16 r squared s to the 4th divided by 9. Okay, so don't get confused. These two things are the same thing, just written in a little bit different form. Alright, and that's it for multiplying and dividing monomials. Don't forget the Google form.